You might heard about multitasking, right? And multiprocessing, right? So multitasking means before going to the thread, right? We have to understand two, three terms. Okay. So one term, the first term is multitasking, the second is multiprocessing, and then third is which is then the third one, which is multi-threading. Okay. And then we'll see what is process and what is thread and all. Okay. So when we talk about multitasking, so what you guys understand about multitasking? So multitasking, like if you see right now, let us say I'm teaching you, right? And if I'm scrolling my Instagram, right? So this is called multitasking, right? So I am the one object, okay, who is performing two tasks, right? One, I'm teaching you guys, and then I'm scrolling a Instagram feed. Okay, now the second scenario, when you go to movie, all right, when you watch movie, I'm taking you guys as an example. So when you watch a movie and meanwhile you attend a call also, right? So this is called multitasking. So if someone asks, one second, if someone asks what is multitasking, so you have to say that the multitasking is a process of executing multiple tasks concurrently, right? So multitasking means executing multiple tasks. Let's say task one and task two. You are doing at a same time. Okay. This is time T1 and the task 1 and task 2. So you are doing on the same time. Task 1 and task 2. Okay. So the multitasking itself, right, can be achieved in two ways. Okay. So what are those two ways are? The first is multiprocessing. Okay. And the second one is multi-threading. Okay. So the term, right, multitasking, you guys are able to understand, right? I'm not going into the much deeper because it's a generic definition. Okay, so multitasking means a person, okay, can do multiple job or multiple task at the same time or concurrently, right? Or we can say that in a more formal way, like multitasking is a process of executing multiple tasks concurrently. And multitasking can be achieved in two ways. The first way is multiprocessing, and the second way is multi-threading. Okay, so let's talk about multiprocessing. Okay, so multiprocessing means, let assume if you see, right, you see my screen, right? So I'm let assume in your computer, just take example, if your computer, you are writing a Java program, right? And you can play a song as well, right? You guys are able to do that, right, in your system?
Yes.
And you can, if you have multiple screen, in one screen you can play, you can watch Netflix, another one you can make typing something, right? So this is called multi-processing. So in that scenario, two process, one process which allow you to type, the another process which allow you to watch Netflix. Okay, so then these two processes are separate, right? So multiprocessing always occur or we can achieve on system level. What does mean by system level? The system level means, like let us assume this is my laptop, right? So in this laptop, right, what is the lower level of that? So when I'm going into the processor or going to the thread, right, so those are the lower level. So on system level you can achieve multiprocessing, okay, which is a part of multitasking. So multiprocessing means you can open one process for WhatsApp chat. We can open one process to watch Netflix. One process is playing your music, and they all are independent. They don't share anything, right? So they are independent. So let them you are developing a Java program, and then you are listening a music. Then you already downloading some movie, and download is also in progress, right? And then you also print a document. So there are four process or five process you are executing at the same time concurrently, and that is called multiprocessing. Clear to you all? Yeah. So now we'll see. Now it's come to the multi-threading. Okay, which is the topic that we are going to explore, right? So multi-threading, right? Okay. So multi-threading basically means, okay, executing more than one thread simultaneously is called multi-threading. If anyone asks you a definition of multi-threading, so you just have to say what is thread and all that is we'll learn. Okay. So multi-threading simply means when you are having more than one thread. Let's take an example. If you are having th, one is a thread. Th, two is a thread. Th, three is a thread. So when you execute this three thread at the same time or concurrently, right? So it's called as multi-threading. Okay. But multi-threading, so see the multiprocessing based on system level, multi-threading is best suited for application level. Which level? Application.
Application.
Yes. Acha. What does mean application level? Okay, so I will just give you one example of application level, how this multi-threading help us and all. Okay. Okay. So let us assume Facebook login page, right? So at the same time, how many like 1 million user are able to log in, right? Right. So at 1 million user at the exact X time try to log in into their account. That is one example. The other example is, let us assume you are having a Word document, right? And you are typing, hey, like let us assume you are typing some article. While typing, you can see that when you type at the same time, someone is showing that your spelling is you did a spelling mistake, right? So what does means? So you are having a document, one thread is helping you to type, the another thread is checking what you are typing. So your typing is having any syntax error or the spelling mistake, etc. If there is a spelling mistake, you will get a highlights, right? A red color highlights, right? So that is called a spell checker, right? So those things are the best example of multi-threading. Clear? So if someone asks you guys, what is multitasking? What is multiprocessing? What is multi-threading? So you can answer, right?
Yeah, we can answer that.
It's not like it's nothing related to code till now. Okay. It's
Yeah,
just a simple understanding. So why we are
it's
going through this? So that later on, when we try to achieve it, when we write a code, we have a better understanding. Okay. Okay. So now if let us assume if you understand properly, if someone asks, okay, I'm a bit confused. Can you tell me the difference between multiprocessing and multi-threading? So what you will say?
multiprocessing is a system level, happens in system level, and multi-threading happens in application level.
Yeah, somehow correct. Correct. So you see that the multi-processing, when we said, it means multiple process are participating, right, to perform a task, right? Correct. When I'm saying multi-threading, so multiple lightweighted threads. Threads are also a sub process, like let us assume a one process when you are playing a music, right? It's a process, right? But while playing a music, to play a music might be that process using multiple thread. You understand? So let assume, let take example. The process P1 is playing Netflix. To play that Netflix properly, the process P1 might have a thread T1, thread T2, thread T3, thread T1. Each one is doing their respective task. And at the end, you are getting the result. Understand? So similarly, in one system, you might have another process, P2, which is where you are writing document, right? So P2 might have 2 or 3 process, which is helping you threads to write your document. And this T1, T2 are kind of sub process, which is having on application level, and P1, P2 are on system level, right? So if
Abhinav, I have a doubt. So can
yeah,
we say like thread is a part of we have multiple threads inside the process?
yes.
Okay.
That is the thing that we are going to understand, right? Okay.
Okay.
So simply, if someone asks, they will say that executing more than one process, right, concurrently or simultaneously is multiprocessing. Executing more than one thread concurrently or simultaneously is called as multithreading. Okay. Now, now take example the next difference. Why we're talking about difference? So process and thread. So now you just take example P1 and P2. So P1, P2 are two different threads. Okay. Sorry, two different process, and each process, right, have their own memory area. So if P1 process storing something and keeping their state and all, P2 are not able to see that and not able to get that, right? So in multiprocessing, multiprocess environment, what happen? One process cannot share the memory with another process. But in thread level, because thread are part of process, so T1 thread can share a memory with T2 or data with T2 and communicate with T2. Understand?
Yes.
Yes.
So each process will have their own memory
Threads.
area, and we cannot share that process cannot share the memory area with other process, right? Is that correct?
Yes, but in
But
certain
thread
point of
can.
time,
Okay.
see, in certain point of time, it's correct on certain level. Okay, which is correct. A process have their own separate memory. So let us assume if you are having your system, okay, you are having 16 GB RAM, right? So in that 16 GB, let us assume your one process is running. If you open your task manager, you can say multiple processes are running. Each will have their own memory, right? You understand?
Yes.
So if you in window, let's take example of window, and if you just open your task manager, go to process or task. So you say task 1, task 2, task 3, right? They all are process. Okay. And if you see all are
Okay.
utilizing certain space or memory, right? Right. And within and to run one process, they might have one thread or multiple threads are helping them to execute the task and do something, right? That will learn ahead. Okay. So if one process, as I said, each process is having their own memory. So if one process P1 want to share the data with P2, which is a costly affair, like it's not like it's not possible, but it's pretty difficult. Okay, but right now you can do that. Okay, so you see that there are one process is running and which is triggering to another process, right? So it means like they are communicating, they are sharing something, right, to another process, right? So right now, if you see, let's take an example. You open a browser and browser is communicating with your console, right? For authentication, authorization, anything. So in, like two processes are communicating to each other, but that is expensive. Okay, understand?
Yes.
But let them, if you are having multiple threads running within a process, they share a common memory or utilize the same memory area. So T1, T2, T3, T4 here they utilize the same memory area. If you see, these are utilize the same memory area. Okay, so that is the thing. So have you read context switching? Like you guys might have operating system as your paper. If not, there is no issue. Okay. So we can say that. So context switching, let's assume if you are working today, right? And you did something you have, and the state, let's assume you shut down your system or you just make it to sleep. And when you open it, it starts from exactly where you left, right? Similarly, with process also this happen. Okay. So it's called context switching. So when one process is executing and a process used to store his state, right? Which is called process context PCB or something. Okay. And what happened when the process restart, it start from the exact where you left, right? So that is called context switching. Okay. So it switched the context. Similarly, in thread, context switching is pretty easy and straightforward. It's less expensive if you compare to process. Okay. So in simple term, you can say that thread context switching is less expensive than process context switching. If you guys don't know context switching, make a note, read it. Okay. Clear?
Yes, sir.
Okay. So why? Because PCB and context switching is a general term. So it's related to operating system. So you must aware about that. If I start teaching those, it will take a lot of time. Okay. Clear? Okay. So now, okay. So now we are done with a basic introduction. Okay. So we'll start with thread and process directly. So you know multitasking, multiprocessing, and multithreading. Okay. To learn multithreading, you have to know what is process. Okay. So first of all, you have to know what is process. We have talked about it, right? So process is nothing. The process is independent program. Okay. In execution means anything which is executing, right? Independent. Let us assume you are opening a browser, so itself a process. So that process, the P1, right? You are opening a browser. So that process, what that process can have. So first thing that have a code, right? To execute, right? Okay. If it's have a code to execute, definitely it's need a heap memory, right? It's have a heap. What else it can have? So it's created a memory. There are certain function which we supposed to execute, right? So it's have stack. You know why you use a stack to execute functions calls, right? And assign memory to local variables. You remember, right? Now, a process definitely have data, right? Global or static variables, right? So, data. So process hold this four things. Okay, general understanding of processes. It's have a code, instructions to execute. Heap memory where dynamic memory allocation happen. Stack where we make a function call, and data that global or static in nature. Okay. So if someone asks you, okay, it's a very good example of process. So can you give me what is any real-time example, like in your system, can you demonstrate? So you just have to open your Chrome or you just have to open the Netflix and play certain movies. That is the best example of process. So each process, like Netflix application, which is running in your system, is not going to share a memory with Chrome, right? Is it going to share? No, right? They both the process will run independently, right? And they don't share memory. Clear? Okay. So process. So process basically when you start a process, let us assume if I start this Chrome, right? And I'm just in my system, this uh, Zoom is running, right? So it's occupying a certain memory, right? It's take a lot of memory, right? And if I switch from one process, let us assume right now I'm just teaching you with the help of Zoom, and if I switch to Netflix, for us it's a very fraction of seconds and all. But if you compare with the thread switching, it will be a like it's take a lot of time to switch, like if you compare with the thread switching and all. So that is the reason they said, like, processor heavyweight, consume lot of memory, right? Independent execution flow, it don't share memory with other, slower context switching. Okay, clear? So process is clear. Process is instruction which in execution. Okay, and the process can hold a code, heap area, stack area, data, right? Process are heavyweight because they occupy a lot of memory. Process context switching is very slower compared to thread, right? Independent execution, they don't share memory with each other, right? So as I said here, right, the process 1 playing Netflix, the process 2 writing program in IntelliJ. So one process helping you with IntelliJ and writing program, another process is helping with playing Netflix. Clear? Now, when you come to the point, so basically what we are learning today, the basic thing we supposed to learn today, thread, right? So whole idea to explain you all of this topic to bring you here the thread. So if someone asks what is thread, we'll say thread in Java we can create and all. No. If you have a process P1, right? So P1 is a bigger unit, you just understand. And P1 can have T1, T2, T3, T4 threads. So thread is the smallest unit of process. Okay. So let us assume if T1 is an execution unit, a bigger execution unit, then T1, T2, T3, T4 is a smaller execution unit. Clear to you all? A thread is the smallest unit of execution within a process. Clear, right?
Yes.
Any doubt for thread definition? So
No.
you can say that, yeah.
Thread is a smaller execution of a process. That's what it
Smaller
is.
execution, not a smallest execution unit or a smaller execution unit. So basically you can also say in that way, the thread is a, let us assume if process is doing 100 tasks, right? Let us assume when you are playing on Netflix, so someone is bringing title, someone is fetching the latest, right? So it's not like one thread is doing everything, one guy is doing everything. So when process start, multiple guys are doing their respective task, right? So the smallest task, right, which getting executed with the help of the execution unit is known as process. That is the complex definition. So better to say that a thread is the smallest unit of execution within a process. I can write it down. Process, clear? A thread is a, okay. Now, a process can have multiple thread, right? And they all run concurrently. The T1 will run at X time, T1, T2 also run at X time, and X time. X time means same time. Okay, it's 12 o'clock or 2, 12, 12 or 11, 11, 11, 11, something. So basically I want to convey that a process can have multiple thread running concurrently. Clear? Okay. Now, because a process have their own memory and thread are the smallest execution unit of those process, T1, T2, T3, T4, means this T1, T2 are sharing the same memory. Clear? Right? The context switching is easy and everything seems very clear. Okay. So thread definition is clear, right? Definition, not how to create a thread. I'm just talking about definition. You guys are able to understand, right?
Yes, we.
Yeah.
Okay. Okay. I will give you one example. So let us assume when I'm let take example of a process here. So I'm teaching you in Zoom, right? So one process is helping me or in my system to connect with US, right? So that one process have multiple. I have not recorded or what? 1 second.
Record.
No.
It's being recorded.
Yeah.
Yeah. Okay. So that is the so one process is helping me to communicate you through voice. Sorry. One process is helping me to connect this meeting. So whole process, right? The meeting is come under one process. Now this process have multiple threads. So T1, T2, T3, T4. T1 is recording. Okay. T2 is screen sharing. T3 is let assume if I am having any annotations, right? Anything, let assume I'm chatting also. So helping with chat. T4 helping with is showing me something, right? The how many times is remaining or something. It's monitoring, right? And after 40 minutes it will disconnect, right? So it's verifying. So how many threads we have? T1, T2, T3, and they all are doing their own task and they can communicate to each other, right? If T4, which is verifying our 40 minutes time, when we reach to 40 minutes, what it will do? It will communicate with everyone. Hey, stop doing your work. We are going to disconnect and we are going to stop this meeting, right? Correct. So process is helping us to enable this meeting room where we are communicating to each other and multiple thread are doing their part, right? And they all threads like this T1, T2, T3, T4 are part of a bigger process which is P1, right? Clear? Now I get notified only 10 minutes remaining. Means one guy is checking my time in certain interval, right? Okay. So thread are lightweighted and thread used to share memory, right? So the basic funda here is we must understand what is thread and what is process, what is multitasking, multiprocessing and all. Okay. Now what we will do, there are it's we have a lot of theory, right? Thread is this, lightweight and all, but the basic thing that we supposed to know how to create a thread, right? So we learn how to create thread. Okay. First we have to learn how to create the thread and then we talk about other aspect of that. Like I said, thread used to communicate with each other, right? How they communicate, right? Thread used to like you can have multiple thread, each thread will do a separate task. How they will do that? So those things we'll learn now. Okay. So there are 4 ways to create a thread in Java. Okay. So majorly most popular and for my understanding only 2 ways. But if you ask someone, if you go through books and all, they will say 4 ways. The first way is extending thread class. Okay. The second way is runnable, you remember like runnable interface? When we are learning about object, right? Object class and all. So runnable interface. So by implementing runnable interface, okay. Third is by using anonymous class, okay. And the fourth is in Java 8 plus, after Java 8, okay. So you can do with the help of lambda expression, which also involve thread class, okay.
So the runnable is the functional interface.
See, runnable is a functional interface, but it's not exactly a functional interface, but you can use it as a functional interface, okay.
Okay.
The reason is functional interface means a method must have one abstract, oh sorry, an interface must have one abstract method, right?
Yeah.
And runnable is having that, okay. So we'll see. I can show you how to use it as a functional interface, okay.
Okay.
So any interface which is predefined. See, basically when they introduce functional interface, they come up with this definition and all. And because of like we already have a certain interface in past, right? From the previous version, which have only one method. So we can utilize them as a functional interface. Okay. So don't think about that functional interface right now. Right now we will to focus on this extending thread class, runnable interface by using anonymous class and Java 8. So we left with 6 minutes. I don't want to start coding today. Okay. Tomorrow we'll start with coding, how to extend the thread class, how to runnable. So we see all the ways to create thread and we move forward, right? With other advanced topic. So let me stop this. Stop.